Lesson 5-3, adding and subtracting decimals. And in this lesson, you learn to add and subtract decimals. Why is it important? Because balancing a checkbook involves adding and subtracting decimals. Let's take a look at this activity. You have experience with adding and subtracting integers. Use a calculator to develop rules for adding and subtracting with decimals. Okay, so copy the table below. Use a calculator to find each sum or difference and complete the table. So you can pause this right now, take out your calculator, and do it with me. So let's find the sum of 18 plus 66. Okay, so using your calculator, you'll get the sum, which is 84. And if we want to add 1.8 plus 6.6, again using the calculator, we'll end up with 8.4. Okay, and if we get 56 plus negative 78, or 56 minus 78, end up with negative 22. And we do the same thing with a decimal. 5.6 plus negative 7.8 will be negative 2.2. And you get 44 minus 50 in your calculator. That should give you 29. And following the pattern, you know that 4.4 minus 1.5 will give you negative, 2.9, not negative. And then you have 220 minus negative 104 in your calculator, or that is the same as 220 plus 104 will give you 324. And this time with decimals, 2.20 minus negative 1.04 will give you 3.24. Okay, so if you want to compare the sums and differences, okay, in column B, column A to column B, you know that they have the same digits in different place values. Okay, and then compare the answers in column A to the answers in column B. Okay, they have the same digits in different place values. And finally, describe how you could find the sum of 6.8 and 9.3 if you know that 68 plus 93 equals 61. That's easy enough. You simply move the decimal point in 161 one place to the left, okay, to get the sum of 16.1. Okay, now with this pattern, we can start learning our concept. Adding and subtracting rational numbers follow the same principles as addition and subtraction of integers. Okay, the first property that we talked about way back, I think in chapter 1, okay, is a commutative property. Okay, for any rational numbers a and b, a plus b is equal to b plus a. Remember, we talked about this as well. Commutative comes from the root word commute, and to commute means to move. So basically, we are moving the numbers, the order of the numbers. So a plus b becomes b plus a. Good example would be, let's say you have negative 7 plus 9 will be equal to 9 plus negative 7 because of the commutative property of addition. So we can move the numbers around or change the order of the numbers, and the sum will not be different. It will still be the same. And another example, negative 8.1 plus 9.6. Again, we move the numbers or we change the order of the numbers, but we still get the same sum. Okay? And so that is the commutative property of addition. The second property, which you all know also, is called the associative property of addition for any numbers a, b, and c. Parentheses a are the quantity a plus b. Close quantity plus c is equal to a plus the quantity b plus c. Okay. Now, what do you notice in this case? Associative means, okay, to associate. And you talk about the word associate. If you're part of an association, you are part of a group. So basically, you are grouping numbers. A plus b has been grouped here, okay, which is the same as if you group b plus c and add it to a. So if you have the grouping of a plus b added to c, is the same as adding the group of b plus c added to a. What you also notice in this property is that the order does not change. A, B, C, okay, remains A, B, C. The order of the numbers did not change. only the parentheses started to move. And that is one main difference between the commutative and the associative properties of addition. Let's take a look at some examples. Okay, so negative 3.5, or the quantity negative 3.5 plus 5.2 close quantity plus 3.1 is equal to negative 3.5 plus the quantity 5.2 plus 3.1. So if you notice, the order of the numbers do not change, and according to the associative properties, if you change the grouping for these numbers, the sum will still be the same. Okay, and that is the associative property of addition. The next property, which we discussed in the past, is what we call the identity property. Simply states that anything you add to 0 will still be the same number, and it will be identical. And that's how one way to remember this. So a plus 0 will still be identical to a, so, or 0 plus a will still be equal to a. Good examples would be 8 plus 0 and 0 plus negative 5.2 would be identical to the number, in this case negative 5.2, and in the first example it will be equal to a. And finally, the inverse property: for every rational number a plus negative a equals 0, or in words, once you add the opposite of the number, the sum will be equal to 0. So in this case, you have 6, add its opposite, which is negative 6, will give you 0. 15.8, add its opposite, which is negative 15.8. That should give you 0 as well. Okay? Now, we will use these properties and the rules you learn from adding and subtracting integers to add and subtract rational numbers. Estimating will help you determine the reasonableness of your answer, and that's why we did the last lesson, because we want to estimate first. So let's take a look at this example. Solve each equation. AM equals 13.2 plus 11.7. First, we estimate to the greatest place value they both share. In this case, it's the ones place. So we round both of them to the ones place, end up with 13 plus 12. So our answer should be close to 25. Okay, and let's find our exact answer. Vertically, 13.2 plus 11.9, bring down the decimal first, and then add as if they're whole numbers. End up with 24.9. M equals 24.9. And if you notice, it is very close to our estimate, and our answer is correct. Okay? Take a look at G equals 231 minus 126.7. The greatest place value they share, or we can round them to the nearest tens place. So the nearest tens place in this case would be 230 minus 130. Okay, that'll be around 100 will be the value. Okay, going back to this one, here, let me make a correction. The greatest place value they both share is not the ones place, it's the tens place. Okay, so if I round it to the tens place, that would be 13.2 would be rounded to 10, and 11.7 would be rounded to 10, 10 as well. So this rounds to around 20, which still makes sense, 24.9. Okay, so in this case, they rounded to the ones place, because as you round to the ones place, your estimate becomes closer, or comes closer to the exact value. In this case, 24.9. Okay. So let's go back to this example. G equals 231 minus 126.7, rounded to the nearest tens place. You estimate our exact answer to be around, okay, around 100. So our exact answer should be close to 100. So, two ways to do this. Let's use pencil and paper. Okay, if we use pencil and paper, we simply do 231 minus 126.7. Okay, bring down the decimal point, subtract as if they're whole numbers, you end up with 104.3. And if you're using a calculator, if you want to, you can end you'll still end up with the same number, which is 104.3. So in this case, G is equal to 104.3. And if you look at our estimate and the exact answer, they are very close to one another. Okay, and finally, let's take a look at C. 8.3 plus negative 12.5. So let's estimate again. Our answer should be close to negative 5 because 8 minus 13 is negative 5. This time it's rounded to the nearest, to the greatest place value position they both share, which is the ones place. Okay, so 8 minus 13 is negative 5. Our answer should be close to that. Okay, and what do you also notice that is that we are applying, okay, the rules of integers when you're subtracting. Okay, like what the song says, same sign, add and keep, different signs, subtract. And since we have different signs, okay, we need to subtract 8.3 and 12.5. Okay, so doing this, okay, we can use absolute values. That means we subtract the smaller number from the bigger number, get its absolute value, and put a negative sign. Okay, since 12.5 is negative, that would be the result. Okay, or we follow the song, same sign, add and keep, different signs, subtract, keep the sign of the higher number. In this case, the higher number is 12.5, and that's the reason why we put a negative sign on 4.2. Okay, so compare with the estimate, negative 4.2 is close to negative 5. Our answer checks out. Okay, if you notice, the rules of integers still apply to what we're doing up to this point. Okay, and let's take a look at the last example for this one, and this is in connection with algebra. Well, actually, the last two examples. Simplifying expressions may involve adding and subtracting decimals. Okay, so you have 4.7x plus 6.3x minus 13.7x. You want to simplify that expression. That means using the distributive property, we basically factor out x. So you're left with 4.7 plus 6.3 minus 13.7 in parentheses, then multiplied by x. Okay, and then using what we know in an order of operations, we go from left to right. So 4.7 plus 6.3, okay, will give us 11 minus 13.7x. Okay, and this is now using the associative property. And if you notice, 13.7 has a sign of negative, and we're subtracting. So that means according to our rules, we need to subtract and keep the sign of the higher number. So if we subtract the smaller number, which is 11, from 13.7, we end up with 2.7. But we know that 13.7 is negative, and 13.7 is the bigger number. We put a negative 2.7x. Okay? Let's take a look at the last example. You use sums and differences of rational numbers every day when you deal with money. Okay, Kiana uses a spreadsheet program to keep track of her money. The printout at the right shows her expenses and budgeted amounts for the month of January. Find the amount of money that Kiana is under or over budget for the month. Okay, so to answer this question, we need to find the sum, okay, of the sums of the budget and the actual amounts. And let's use a calculator for this problem to be solved faster. So we add 159.14 car payment plus 195.63, and we're adding all of these down in the budget. We end up with 649.8 $19.77. And let's take a look at the actual expenses. Car payments is the same. Car insurance is the same. We have fuel, which is a little slightly higher, 37.32. Car repairs at 135.67, slightly lower. Entertainment, stayed home a lot, so $52.44. And savings in the bank is the same as $50, end up with 630.20. So if you notice, the actual is actually smaller than the budget. Okay, so the actual is smaller, so we do 649 minus 77 minus, 649.77 minus 630.20 will give us $19.15. So Kiana is under budget by this amount, $19.57. And that's it for this lesson. Thank you for watching.